Welcome to springlib.
There are two extensions of radioactive decay that are being described here, each opposite processes of each other. One in which a proton decays into a neutron, and a neutron decaying into a proton. Let's look at both of them. One of these forms is known as beta decay. In this case, when a nucleus tends to have too many neutrons, such as our old friend carbon-14, it will cause one of the neutrons to actually decay into a proton, such as here, where carbon-14 will decay into nitrogen-14, a stable form. This will cause the ejection of an electron by this process. Now, if it stands to reason that some isotopes must have too many neutrons to be stable, it also stands to reason that some isotopes will have too few neutrons to be stable, in which case we see an opposite form known as positron emission. So an example would be the radioactive isotope of magnesium-23. As you can see from looking at a periodic table, magnesium, more often than not, will have a mass of 24. So this is too few neutrons for it to really be stable. In this case, instead, a proton is going to decay into a neutron, as we see here. And instead of an electron being ejected, it will instead be what's called a positron, the antimatter equivalent of an electron.